What's happening? It's your boy Vbot, and today I'm going to be showcasing two methods of migrating from Planetscale to Neon. It ended up being more of a guide on how to migrate from MySQL to Postgres, so I think it will kind of work independently of whatever provider you have. But in my specific use case, it involves Planetscale and Neon, and also my ORM, which is Prisma. So if you have those dependencies in your project, then this should work pretty much seamlessly for you to get data migrated across. So yeah, hope you enjoy. Let me know of any comments you have and any issues that you encounter, and I'll be happy to respond. Cool, let's get into it. So I won't go into too much detail about the Planetscale decision to deprecate their free plan, because I think there's been plenty of discourse on social media over the last few days. But in short, if you are a user on a free plan, then you have until April 8th, 2024 to migrate it to the Scalar Pro plan, which starts at $39 a month. If you don't do this, then as I understand, your database will be put into sleep mode. So essentially, when you don't use your database on Planetscale for a while, they put it into sleep mode. So the same thing will happen if you don't migrate. And this got me thinking about alternatives to Planetscale. It's a very unique offering, and I want to go out and say that I really like the team. I really like the product and everything they're doing. I just am not so happy with this decision because it prevents future users of Planetscale getting into this amazing platform, purely because now the barrier of entry is so high. A lot of startups, people just building, proof of concepts, want just a database that they can kind of just mess around in and, validate their idea, and then maybe move on to a paid plan if it's successful. And this is essentially taken away from the user. So I was pretty sad about this, but I started looking at alternatives, and it brought me down two paths. The first one being AWS Aurora Serverless. This was great because I could stick with MySQL, because Aurora, the engine, has a MySQL flavor. But the issue here is that this DB, when hosted on AWS, actually ended up costing more than Planetscale just to run on the lowest possible plan. I think it ended up being about $43 per month or something like that. So I was like, this still doesn't serve the use case of a developer going down the road of just trying to prototype an idea. So this kind of ended up being Neon. Neon was the one that I wanted to go with. The problem with Neon is that its underlying infrastructure uses Postgres, which is fundamentally different from MySQL. It's actually a little bit more complex, in my opinion, than MySQL. And with that complexity comes a lot more power. So I might really enjoy this decision in the long run. So I started looking at ways to get it migrated to essentially to Neon. But firstly, it would have to be migrated to Postgres. And I just basically found this article over here, which is, the Neon official way of migrating it. And this mentioned pgloader. And I went down this route and it ended up working really great with a few caveats. So in this video, I'm going to be showcasing two methods of migrating your database, and you can decide which one suits you the best. So I'll post the link to this because there's a few things you need to go through. But essentially, we needed to get pgloader. And I'm running a M1 based Mac. And the problem with this is that the pgloader package has a little bit of incompatibilities with its dependencies. So I eventually found this article here. After unsuccessfully following the advice here to install it via Homebrew and then running into all of the compatibility issues, I found this comment here which really helped. And it essentially involved just downloading the release directly from the repo, and then running a make on the repo to build it, and then just using this command directly to migrate the DB across. So I just spun up a quick T3 repo here, just because it has basic CRUD, and I used the Planetscale flavor. So you'll see here's my old connection string from Planetscale. Before you rats get any ideas, I'm going to be destroying this database before publishing this video. So none of your tricks will work. But I needed to show you guys the connection strings because there's a few things you need to do to manipulate them to get them working successfully. So I'm just going to run a pdev here just to spawn this server. So this thing's running in the background. And what you're looking at right now is the config.load file, which is essentially sitting in the pgloader repo that we downloaded, just purely downloaded and ran a build on. I did this before starting the video because it takes a bit of time to run the build. I think it was like 10 to 15 minutes actually. I'm not too sure why. Maybe there was some optimizations I could have made to run quicker. And then I created this file, config.load, which creates a config for pgloader to migrate it across. You can also put these commands in the command line, but I was messing around with it and I wanted to do a few different things. So yeah, you'll see the basic schema Prisma that comes with T3, which just has a post. And running on Planetscale over here, you'll see that I've created 2 test posts over here, just with some basic data to showcase what's going on here. So the DB that I'm using has no real data, it's all test data. So if we go over here, you'll see that the most recent post is another one. This corresponds to the one that we're picking up over here. So that's all good. So in our command line, I'm going to create a new terminal window over here. We're essentially going to take that command from here. So this essentially serves in place of, you can follow this guide pretty much to the T, but this basically replaces that pgloader command, which is coming from the command line, just because I couldn't get that to work. And here you'll see the input is actually the config file. So you would have to just do that. But before I go ahead and do that, I just want to show you how to actually get the connection strings in their correct format. So you're going to want to go to your Neon dashboard. Again, this is a test DB. It will be destroyed. And I need to show you the connection string so you can do this yourself. So we're just going to copy this over here. We can leave pool connections out of it. I think it might support pool connections on these commands, but just for safety, don't. Make sure that your database is selected and the branch is selected. Remember, there's 2 tiers there. And then we're going to come back here to our config load. And we see we have from, which is our Planetscale. It's essentially our Planetscale string as is, except I've appended the SSL mode required to the end of it. And then we're going to put it into over here. And then if we look at the instructions over here, what they want you to do is to take this part of your connection string, right? So this is the part that comes essentially after your password. And you want to put an endpoint equals to with a semicolon on it. So over here, what we'll do is we'll literally, there's our NeonDB owner. That's the username. And then we'll want to, yeah, so right after the owner, we're going to do an endpoint over here. Let me just take a look here again. So it's endpoint, but before our password. So we're going to take our endpoint, which is essentially this part of it, which is auto-generated, and we're going to do there. And then we want a semicolon there right before our password. I just want to confirm that this is in the correct format. If I view this, so it ends at Q. Yeah, so that looks correct. So now we're going essentially from MySQL into Postgres. Then there's a few connection options over here, which I'll explain. So with quote identifiers, the reason why this is really important is that Postgres will migrate across everything lowercase. And obviously that's the preferred way of doing it because it makes your commands a lot easier, your SQL commands. But then it's kind of conflicts with my ORM of choice, which is Prisma. So this post will essentially be made into like that, essentially like that. So we wanted to actually keep those quote identifiers because then it'll keep our casing. But then the problem is that whenever you run the commands, you'll have to essentially escape the, basically quote these out just so that it knows what case they're in. You specify in the case. And then preserve index name. This is a really important one because this, if I could get this correct, or if this worked as I wanted it to, then I wouldn't have to even show you the second option of migrating your DB across. But unfortunately it didn't. So if we go to the documentation over here, this is pgloader's documentation in the MySQL to Postgres section. And over here we have the preserve index names. And this preserves all your index names, which is great. The problem is on all of your IDs. So I think it comes over here. It says, even when the option is preserve index names is set, the MySQL primary key indexes named primary will get their names uniqueified. And this basically butchers your Prisma schema. And this was a big problem. But I'll show you that shortly. So essentially we're going to run pgbuild and then we see config.load. So we're going to put our config.load in here. And this is going to run the migration from this into this. Let me just explain the last part here. In Postgres, we have the concept of schemas, and the public is the default schema. So you can think of a schema almost like a subset or subdivision within your database. So you'll see my database name is NeonDB over here, the default one it comes with, but it's actually going to migrate it into the public schema. And if I don't put this command, what it's going to do is take my original DB name, in this case, Polylink, and it's going to migrate it into a schema named Polylink, which is no longer the default schema of public. And then Prisma's default client tends to want it in public. It reads from there. I know you can append the schema onto the connection string at the end when using Prisma, but that didn't work as intended in my case, and it kept on trying to read from public. And this was really confusing. I'll show it in the SQL client in a bit. So that's really important. You got to alter the schema. It's going to try take the original DB name as the schema. You're going to make it public before it does it. So we're going to run this now. I might speed up the video at this point because it might take a little long, but I'll show you exactly how it works. Sorry, my bad. I've got to just first go into pgloader before I can run that command. Oh, sorry, change directory, pgloader. I don't think I changed there. Now it should run. So yeah, it's like logging everything. It's obviously checking the syntax of this config.load, making sure everything is cool. And you'll see now it's established a connection to our initial DB, the MySQL one, and it's migrating into the Postgres one over here. I think I'm going to use this part actually just to take you through your schema and how it might change when you migrate to Postgres. So there's a few things that are different. So if you look at my initial DB here, test post, another test post, we have public, which is actually a Boolean in our schema. And in MySQL, it uses a bit format for Booleans. But in Postgres, these are actually set as true and false, respectively. So you're going to literally have to go through all of your types and make sure they're migrating to the correct types. pgloader does have a few options to put them in the format you want with additional syntax showcased in that document that I'll attach. But over here in our schema, sorry, not there, in the Prisma docs, I would advise you just to go through the models and see what the default model types are for each one of these. So like in the Boolean format, we'll see Postgres, it's actually a Boolean. MySQL is actually a tiny int. And that's where we're going to need to modify our data even at a later point if we don't use pgloader. So that's just something important to note. There's a couple of them that might have a little bit of gotchas, but for the most part, it's fairly seamless to get it migrated across. Cool, so that's worked perfectly in terms of timing. You can see that there's the schema that I was speaking about earlier, public post, and it's migrated two of them as you saw. So this worked out perfectly. Now we're going to want to change our connection string, but not before modifying our schema over here. So here, our provider, we're going to want to change to PostgreSQL. We don't need this relation mode anymore because that's more to do with the foreign key constraints that used to exist on Planetscale. I don't even think we need it on Planetscale anymore. But yeah, that should be pretty much all good. So now we're going to want to change directory, go back one, so we're back in our project. And then once we're in our project over here, we are going to run a pdb pull. And the pull is not really a common command, but I'm going to show you essentially what pgloader has done to our schema. Oh wait, sorry, yeah. Over here, we're going to want to go into our env now, and we are going to want to actually get the database string that we've migrated to and replace it over here. And then we're going to do a db pull. And here's our schema over here. So if you don't mind your schema getting slightly changed, then this method is the best. It takes your schema and your data across fairly seamlessly, and it also accommodates for the type changes. For example, from the Boolean, the bit type into Boolean type. But now you can see actually what's happening in the DB. We have one of these annotations over here, which you can use in the schema yourself. But we can see that it's actually named this itself, and this is because primary indexes need to be unique on Postgres across your schemas, or I think in the same schema. I'm not entirely sure of that, but basically they need to be unique you can't just have an ID in a post and an ID, let's say, in a user. They need to be unique. So it does this, even though we've set in our config load to preserve the index name, it's doing that on all the indexes it can, but on the ones where it needs to uniquify it, that's exactly what it's doing. And you'll see that your schema on a large schema starts to get really complicated. This for me doesn't also look that great. So now I'm going to show you the second way we can go about migrating our schema and our data across, but it's more of a manual method, but it'll preserve this. So we're going to basically we're going to revert our schema right now. And then we are going to clear this console so you can see what's going on here. We are going to run a pscale. Just quickly get the Planetscale documents for the CLI. So we're going to want to just basically dump our DB, right? So I already ran a pscale auth login, which basically logs me into my pscale instance. And then we're going to want to do a dump of our database. So it's pscale database, and then dump database name, branch name. So pscale database dump, and then database name, which in our case was Polylink, branch name, which in our case was dev, which was not the main branch. And this is going to basically establish a direct connection to Planetscale's APIs. And in the folder that we're currently in, it's actually going to run a dump of all the data and the tables. Okay, so I'm going to go in here. It's busy dumping the tables over here, like you can see. And there's our folder that's constructed. While this runs, I'm actually going to go into our DB and manually clear the info. Cool. So you can see it successfully ran. And there's our schema over there. And this is our post. But the schema is not necessary because we already have it in Prisma over here. So I'm going to just essentially, with the current connection string being now neon, I'm going to take our schema, pretend that we didn't do the pgloader migration. We actually just have a blank DB here. But just to make sure, I'm going to run a pdb push, which is a Prisma DB push. And that's basically going to take our schema, and it should prompt us to overwrite because now we're messing around with what pgloader's done on the default schema in terms of, let's say, the annotations, etc. Can't seem to be reaching our DB over here. Just going to run this again, make sure that there's no issues. Otherwise, I'll have to go into the neon instance to make sure. Okay, it looks like we've got a connection here. Sorry, my face might be covering parts of the terminal, but I'll explain essentially what happened. But it's the standard Prisma DB push. Oh, it looks like we have a syntax area. I think we might have to run I think it's a force reset. We're gonna have to run a force reset, I think. Let me take a look here. Yeah, I see it's got some like preventative measures for you to overwrite the schema. So I think the force reset should work on this DB. Cool. So it's saying here that it was successfully reset. Sorry, my face, I think, is obscuring this. And now it should be pushing our schema over here. Cool, we're good. I'm just going to clear this so we can go back to the top. So now it's essentially taken the schema and it's reset it, right? So if we go to our Neon console here and we look at, I think we can go to our tables, you'll see that even though it's successfully migrated using pgloader, now there's no more data in this post, okay? So that's good. And now we can also see that our post, this is the post that's actually come from the DB push, not from the pgloader. The pgloader has essentially been overwritten when we force reset it. And then what we're going to want to do is go into our data. It shouldn't take you too long, depending how much data you have. But we're going to ignore our schema because remember, this has already been accounted for. But we're going to go to our post. And over here, we're going to change, because the syntax is slightly different. I think we're going to first change the double quotes to single quotes. And we're going to do that globally. Do that first, otherwise the next change is going to be overwritten by this. And then we're going to do the backticks. And the backticks must become double quotes in the syntax. Now, this is not going to work yet. This data isn't fully compatible because you'll see our public, which is a Boolean on our post, is actually still in 1. And we're going to want to put this in true, which is the equivalent of 1. And the reason why we're going to want to do this is because this command will fail if we try and migrate the data using an incompatible type. Now, again, I advise you to go through the Prisma schema and see what types are compatible. And if you're doing the pgloader method, you can account for a lot of these, but this is more of a manual method that preserves our schema naming. I like the fact that the schema just rather stays in a slightly more better looking format. Then we're going to just take this post. So for every single table, it's going to create one of these. So schema, and if there's data in it, also the data. And we're going to go into Neon, and we're going to go to our SQL editor. We're going to make sure we're in main or your branch of choice and the DB that we want to go to. And we're going to just paste it over here. You can also do this in your SQL clients, and you're just going to run it. Column public is of type Boolean, but expression is of type integer. Oh, my bad. I think this is where I made a mistake. Yeah, I didn't do these are two posts. I didn't do the last post. Well, sorry, the first post with the true as well. And now we can take these records and we can run them here, and then it should run. Bang. Now, if we go look at our database, sorry, our tables, Neon public, which is the schema I mentioned earlier, and we go to posts, you'll see we've successfully migrated those records across. And there it's using the true Boolean format native to Postgres. So yeah, I hope this has been informative. I hope this helps you migrate your data. Let me know of any gotchas that you run into. It'll be interesting in larger data sets to see how this works. Again, that's why I say pgloader for really big databases at scale. It might be a lot easier and quicker, especially so you don't get a little bit of data inconsistencies while your users continuously add data. But I think you could use this strategy in combination with the branching strategies that exist on Planetscale and Neon to get your data migrated successfully. So yeah, hope that's been really helpful, and I'll catch you guys in the next one. Peace.